Today we will begin our new unit on linear equations. We've been dealing a lot with solving equations and general algebraic relationships. This new unit, we will take those relationships one step farther and we will explore linear equations. Today we're going to talk about direct variation. And it is the relationship where one variable is a constant multiple of another. Let's take, for example, this table here. We have time and we have distance. And you can see that as my time increases by 1, going from 1 to 2 to 3 to 4, at the same time, the distance also increases, but in this case, from 10 to 20 to 30 to 40. So there's a constant multiple of 10 between my time and my distance. So this is a direct variation. If I extended this to 5 seconds, I could figure out that my distance traveled would be 50. Same for 6 seconds, becoming 60, and so on. This also leads to something known as the constant of variation. So if I have my distance d, let's call it variable d, and then my time, if I divide them, I'm going to get this constant of variation k. So this is my constant of variation. Now this constant of variation in this case will simply be, if I extend the page, 10 over 1, which equals 10. So every time I go up 1 in time, I know I'm going to go up 10 in meters. Now let's look at an example. I have Ethan, and he works at KFC, and he earns $7.50 an hour. I'm not sure if that's actually the minimum wage right now, but let's just go with it. So I know that Ethan, after 1 hour, will earn, I'm going to do this in blue, $7.50. After 2 hours, he's going to earn $15. Then 3 hours, he's going to earn 50 cents, and he's going to earn $22.50. And then he's going to earn $30 after 4 hours, and $37.50 after 5 hours. So every single hour, he's going to get paid another $7.50. And for a table of values, that's one way to represent this. Another way would be to represent it as a graph. So generally with the graph, we put time on the bottom, so I'm going to have hours here, and going this way, I'm going to make it maybe in black, I'm going to have pay, so money. There we go. So starting at 0, I'm going to create my grid. I have 0, 1, 2, 3, 4, 5 hours, because that's all the data I have. And then going up back this way, I'm going to start here at 750, make it easy on myself. Skip here to 15, 22.50, and well, that'll be 30, and this will be 37.50. So that's my grid. Not the greatest graph I've ever done, but this is my grid. So after 0 hours of work, Ethan makes $0. After 1 hour, makes $7.50. 2 hours, 15. 3, 4, and 5. So we can see that this is kind of a direct variation. And we can actually plot a line going from dot to dot to dot, and we can even extend it out to here for 6 hours, 7, 8, 9, and 10, and so on. So this gives us a very good indication about how much money he could make over time. So this is a graph, and I can just here goes right to 0. And this is an important point. If the graph starts at 0, 0, this tells me it is direct variation. And that's if and only if the graph will start at 0, 0. So it's a direct relationship starting at 0, 0. And then my final question, just to finish off here, is how much will Ethan earn after 9 hours of work? And this is something I can now express algebraically. So here I have a table, and I have a graph, and this one will be algebraically, so I can put it into an equation. So the pay, P, that Ethan earns will be equal to $7.50 for every hour H that he works. So P, if I want to know how much he's paid after 9 hours, I substitute 9 for H. So then P, extend this out. P is equal to 750 times 9. I'll get my trusty calculator out for this one. 9 times 7.5 gives me 6750. So at the end of 9 hours, Ethan will take home 6750 minus any taxes that he might have to pay.